Evening to all the participants. So yesterday we have seen some of the uh, basics about the AI as well as the machine learning. I given some basics about the machine learning model to construct the machine learning model and others. So today
Start
we are
చేస్తారండి
going to discuss 1 minute. 1 minute.
ఓకే
Hello. Uh, uh, who will what you will get that? Yes, yes, you can go. You can go and come on Monday. Okay. Yes, yes. Okay. Thank you. So sorry for that. Okay. So today we have to see the next level of the artificial intelligence, another one application or another one sphere of in that particular field, that is a generative AI. So people, we don't know exactly directly about the generative AI, but everybody nowadays we heard the term that is a chat GPT. Whether it is a, you are the educated or uneducated, whether you are a computer science, civil or mechanical, or engineering, arts student or school student also, everybody they are using that chat GPT. Even though my son also using for doing any homework from the school level, so he knows better than me how to use the chat GPT. I hope everybody have the experience with that for chat GPT. So in one aspect it is good. So in another one aspect it is completely spoil our creativity, own our human intelligence idea also, because you are completely depends on that particular chat GPT. So what we can able to get, so what, suppose if you want to write some application letter for your HOD or principal or any grievance you are want to give, just you type that content. Even though if you are type the letter in the grammar mistake also, it will give the nicely, it will give that a letter drafting. So that means what we are getting from the chat GPT, the chat GPT will generate the contents. You got it? Simply you are give the leave example leave letter application format. When we are typing that, you are getting the nice letter. So you are giving the only one word. You are giving the only one word as an input to the chat GPT. So the chat GPT is prompting or responding your one word, and it will generate the more text, correct, from that your single word. That means your single word, you as a input, it generate the more number of text characters. One letter, one word or two or three words only as a input, it generate the more number of words. That means it will generate the more number of data. You see that word generative AI, it's a simply we can say that artificially AI. Already yesterday we discussed that it is a AI is nothing but the artificial. So we are creating the data artificially. We are creating the data artificially. Where what is the use of particular that one means? So yesterday I told you that for when we are build that or construct the machine learning model, we need the data. Data is a primary purpose or primary important part when we are build the machine learning model. If the model predictive with the more accurate, so data is very very important. In some situation we cannot able to get the data. Okay, in some part of the application and some part of that part we may not able to get the more active data, more quantity of data. Okay, so from that available data I have the small part of data. So from the small quantity of data or from the small part of data, we can able to generate the more kind of similar kind of data. So that is the concept of generative AI. So the word itself, simply shortly we can say Gen AI. So that the meaning is that we can generate the more similar kind of data. Okay, that is a simple idea about the generate AI. One of the simple application or example every day we are using that the chat GPT. So chat GPT is the one of the application or one of the, it is the form of the generative AI. Okay. So now you see, so you assume that this is the data point. Okay. So today also we'll make our session a little bit interactive session. Okay. So this is the data points. Anybody tell me what is the mean of the particular data points? Just you put it in the chat box. What is the mean? Mean is 50. Okay. So your HOD itself answering. Sir is a more active in that session. Okay. He is the first to answer the person. Okay. So answer is 50. Correct. So what is the how we will calculate the mean is nothing but the average. Okay. We will calculate all the values and divide by the total number of data point samples. So here how many samples are? 8 samples are there. So okay. So we got the mean is that 50 value. What is the standard deviation? So standard deviation little bit formula is a little bit lengthy. Okay. So now you see that. So mean is that 50 and the standard deviation is 19.68. Okay. This is the one data set. The data sets values are 20 to 80. Okay. I will give another one data points. Okay. Another one data points. So the data points starting from the 38 to 65. So this is the your data points. You assume that this is the one data set. So first I given one data set. The data set value is that 50 and the standard deviation for the particular data set is a 19.68. Okay, standard deviation, you know the formula variance. Square root of the variance is the standard deviation. So standard deviation is that PPT is not visible. Okay. So what is the mean of the second data set? So what is the mean for the second data set? Second data set also same thing is 50. Okay, both the data set. Okay, so both I have taken the different data points, but the different data points, but the mean value that is average point is that 50. Okay, so what is the concept of the mean value? And here this data set standard deviation is 9.64. Anybody can interpret the difference between the mean and the standard deviation. We have taken one data set, any data set, and we can find the value mean. Another one is the standard deviation. So mean is nothing but the average. Mean is the both the data set. The mean normally mean is the average. The average about the particular data set is the 50. But the standard deviation value is different. Anyone can able to interpret the what is the use of the standard deviation? If somebody is a max background or some statistics faculty, they can easily. What is the use of the standard deviation for finding the standard deviation for the any one data set? What we can able to interpret from the standard deviation value? Anybody? Because this base will be the very, very important when we are going to use the generative AI. Nobody is having any idea. The standard deviation, what is the use of the standard deviation or what we can able to interpret from the standard deviation value for a distance. Okay, I will tell you another one example. You see that one. I hope you can able to see this one graph. Can you able to see that one? Here, I plotted the two graph values. Okay, one is the blue color, another one is the red color. So both the curve, both the data, that is the data points I plotted, I marked the data, then after that I draw the curve. So both the curve, the mean value is the 50. But the red one, the standard deviation value is 10. Another one, the standard deviation value is 5. But even though both the data points, both the curves, the mean value is average. Mean average value is same. But only that the standard deviation is different. One is the 10, Another one is a 5. I think now you may get some idea. So again, HOD sir is answering. Excellent. Okay, so that means you see here, both the data points, I am saying that 50, you see that the curve, what is the 50 point? 50 is the mean value. Mean means the average value. What is the average value? What is the use of the average? That means the data points are closer to the mean value 50. Correct? The data middle value for the, not only the middle value for the data set is 50. But when you see the standard deviation value, if the standard deviation value is higher standard deviation means the data points are scattered from the mean. You see that the red color, it is start from the 20 to 80. The minimum value is 20 and the maximum value is 80 when the standard deviation is 10. You see the standard deviation 5 means what is the meaning that the data point is starting from 35 and the maximum is 65. That means the data points are very closer to the mean. That means whenever you are taking the data set, you find the value mean. Mean is nothing but the average. But when we are taking the value of standard deviation, if the standard deviation is closer to the 1, that means that the data points are very closer to the mean value. Okay. If the standard deviation, because we cannot able to see the individual data points, we cannot able to see the individual data points, but we can able to easily calculate the standard deviation. Once the standard deviation value is very low means the data points are closer to the mean value. Okay. And the standard deviation high means the data points are very far away. The data points are scattered. That means how the distance between the data points to the particular your mean point. So that is the use of the standard deviation. Okay. I hope you may heard this term, that is a Gaussian distribution, the data distribution. You may heard that one rule is there, that is 68, 95 and the 99.7 rule. Normally we call, you see the curve, the below one, the colored one. Here you can able to see, here the color, it is that the shape of the curve is the bell curve. The shape of the curve is the bell curve. What is the use of the bell? Bell means if you cut the bell in the middle portion, exactly will get the both half should be the same. You got it. When you take the bell, you cut the middle portion of the bell, midpoint of the bell, left hand side and the right hand side, both half should be the equal, same position. That means the shape is the same shape. Left hand side also, right hand side also. That means when your data is distributed uniformly, that means when your data left hand side and right hand side, everything is distributed uniformly, mean you will get the bell curve. When your data is distributed uniformly, it is a bell curve, mean then your data distribution is the normal distribution or the Gaussian distribution. Now it is that the point, what is the 68, 95.9, 99.7. You can see that sigma is the standard deviation. So 68%, because we cannot say that all the data should be closer to the mean value. When we take the one data set, almost 68% of the data are within the closer to the one standard deviation. You see the more number of, then 68 to the 95, that range of values only within the two standard deviation, and hardly 2.3% of data only the third, that means the third sigma, that means the three standard deviation, one standard deviation, two standard deviation, and the three standard deviation from the mean value. So that means very closer, if you more data are closer to the mean value, that means a one standard deviation, two standard deviation, and a three standard deviation. That means when you have the data set, if the data are distributed properly, then you may get the some bell curve of shape. Here you see that some of the symmetrical distribution, when you have the bell curve, then your mean value, the median value, then the mode is the what is the highest maximum value in the particular data set. All the points will be the same point. Other will be the positive skew. That means a more number of the, you see the tail end, the positive tail end more in the positive side mean it is a positive skew. If the more tail in the negative side mean it is a negative skew, then your mean median will, that point will be different. Whenever you are taking the data set, mostly your data set should be the Gaussian type of data. Okay. You see, this is the one. You see this graph, this is the emerging technologies in the year 2024. Okay, this graph you see that. So every year the Gartner is the one American based one research forum. So every year they may release some of the curve. The curve is we can call it the hype cycle. The hype cycle having the rising edge and the peak edge, and it is a coming down. Again, it is going to the rising edge. Okay. So there are the 1, 2, 3, 4 platforms or 4 categories there. So you see that the last year among the all the they may plotted almost the some 30 emerging technologies. So here, which one is the peak stage? You see that the curve, you can able to see there, generative AI will be the peak stage. That means this particular technology or the particular AI, generative AI will be the Gardner hype cycle. They identified that. So this technology or AI will be the generative AI will be the peak of the particular period. So once again, based on the first example only, okay, another one thing. So again, I will take the some data set. Okay, I will take the data points. Total, how many data points are there? 10 data points are there. You assume that the 10 data points are there. If I add all the values, the value is 500. Okay, the value is the 500. I will get the mean value 50. Okay, so in the data set, I have to add one more data points along with the data set, but I want to keep the mean value should be remain same 50. What will be the particular data point? Already I have added the 10 data points. Assume that the mean of the particular data set is 50. So now I want to add one more data points along with the data set, but the mean should not change. I want to keep the mean should be remain same. What will be the particular data point? Anybody? I hope you got my question. So already 10 data points are there. The mean for the particular data set is 50. So now one more data points you have to add, but the remain should remain, keep that is 50 only. Again, SAR answer is the first answer. So the value is the 50, correct. How? So already 500, if you add one more data point, that will be the 550 divided by 11, it will be the same answer. Correct? Okay, I got the 2, 3 answer. So now the data point is 50. Now the data point is 50. Now, the same thing. Instead of, sir, 49 will not be correct, sir. 50 is the right answer. So now, the same data set, what earlier I told, the same data set only. Okay, here I want two more data points. Add two more data points, but the value should be remain, should be the mean should be same. What are the data points? So earlier we added one data point, and your answer is 50. So now instead of one, you have to add two more data points, two data points. Already 10, we want two data points. So I got one answer, 4852. I don't know the logic why everybody is typing 4852, 4852. Any reason is there? Any significance is there in the number 48 and 52? Very good. Okay, I got Sar also correct answer, another one also. So total, how many numbers will be there? So combination of two numbers, sum is 100. So that means it is a infinite. Even it is not a two numbers, or 1.0 also there. Correct. Now the day two. 2 data points. What I told you, so we have to add 2 points. Now already 500. You assume that already 500, the data set. Now the total should be 600, correct? I told you add 2 points. 10 plus 90 or 20 plus 80, 30 plus 70 or 1 plus 99, 2 plus 98, correct? Or 1.9 to the 99, 1.9 or 1.1. So we have the infinite number of combinations will be there, correct? So you see very interesting things. Already we have the one data set. What is the mean? The mean value for the data set will say give the shape of the data set, correct? Average about the data set. So without changing the data set or without changing the mean value, we are adding more data points. We are keeping the same mean value. Earlier we have the only 10 data points. Now we are generating the more number of data. So every points, every numerical value is the one data points. So earlier in your data set, we are having the data points with only the 10 only will be there. Only 10 is there and the mean also same now. So we are adding more number of data points. We are increasing the data points more number and we are keeping the same mean value. That means we are generating the more data, correct? Already your existing data only 5 data points. This is the original your data set, correct? This is the original data set. So without affecting the mean or shape of the data points, because we are creating artificially, we are creating the data. So it should not affect the original data set. Without affecting the original data set, we are adding more data. We are generating the more data. That is artificially we are generating. So already we have the 10 data points. The 10 data points, we have the mean value 50. So if you are adding, keep on adding the more point also, we didn't touch that value of the mean value. So this is the simple logic behind that your generative AI. We are generating artificially, we are generating the more number of data points, even though we are keeping the shape of the original data set. I hope you may get some idea about the generative AI. Okay. So now you see that what is a traditional your AI will mostly use for the, you see, generative AI purpose, main purpose is we have to generate the data. So data in the sense, not only the text data, we can generate the audio data, we can generate the video data, correct? Or we can generate the image also. So any kind of data we can able to generate. You see, for example, when we are finding some, every home we have the CCTV record is there. Most of the home we are having that one. So we have to find some incident happen in your home. Okay. So you assume that in your CCTV you recorded the 10 minutes video only. Okay. Due to the some the power issues or something happened, the video is the CCTV not able to record it. So you have the 10 minutes record video. From the 10 minutes video, we have to what will be the video from the 11th second. What will be the video for the 12th minute. So 10 minutes you have the video, but you don't have the video of the 10.1 second. Particular next second, you don't have the video. You don't have the particular frame. So you have already 10 minutes frame. The video having the n number of frames will be there, correct? So from that 10 minutes video, we can generate the what will be the sequence of the next event. What is the sequence of the next frame we can able to generate. So that is the main concept of the your generative AI. So already we have the some set of data is there. With the same data, we can generate the more form of data. Okay. So generative AI. So it is a kind of AI technology only. So yesterday we have seen that AI, machine learning and deep learning. So what is the concept of the deep learning? So deep learning is the mainly used for the neural network. You have the more number of machine learning algorithm models are there. If your machine learning model, if you're especially if you are using that some neural network based algorithm, then we can call it as a deep learning model. Neural network based algorithms, or we can call it as a deep learning. Okay. So with the help of your, that means here the AI, generative AI inside it is a some deep learning model, some new neural network based model. So that models only generating the data. Okay. So the data may be the either text data or image data or the audio data. So that data normally we call as the synthetic data. Okay. We'll see next what is a synthetic data. So you have some kind of data is there. From the data, we can map some patterns. We are generating the sequence of data. So from the sequence of data, we can able to identify some patterns. We can identify some association between the data in your original data set. That is the main purpose of the your generative AI. So nowadays the generative AI play the major role in your main team, that is your cyber threat detection also. Okay. So you see the key difference between the predictive normal AI. So you see that will it rain tomorrow? What will be there? What is the normal your machine learning model? It will say that answer yes or no. Correct. But we have to give the complete weather report. If it is a raining, then what will be the raining, that how much rain, all the details, more detailed report. If you want to get it, then we have to use the generative. For example, what we are saying that in that generative your chat GPT, you are typing one symbol, two letters. You are typing the two sentence about the leave letter. Correct. It will give the more detailed about the your leave letter it is giving. You are giving the two sentence. From the two sentence, you can get the more than 10-15 sentence for very nice without any error or nice flow sequence letter. You can able to get it. Again, you have to reintune the same letter. You will get the different letters. That means we are getting the generative AI with the help of we have to get the some realistic report, a detailed report we can able to get. So that is a major difference between the your generative AI as well as the normal AI. So now you see here, this is the left hand side, that is the original image. You had the term data augmentation as well as the synthetic data. Can you able to see any difference between these two? Somebody is working on the image processing, they may use this term data augmentation. So your original image is the dark. Correct. From that, I have to make the two part. One is the augmented data, another one is the synthetic data. Can you able to see what is the difference between these two? Data augmentation, another one is a synthetic data. Anybody? What is the difference, these two images? I did the two things. So rotation, Kalpana ma'am answer one, that is the rotation. What is the rotation here? So in the, you see here, the original input image is the one dark image, correct? So that same image only I have to change the orientation of the particular image. You see the same image only, same dog only. I have to change the orientation of the same image. I have to make the four images, but the same image only. From the same image, I have to change the angle. I have to change the angle. So I have to rotate the particular image. I have to rotate the particular image. I have to change the orientation of the particular image. But you see that that is a different ways. Okay, what your answer is correct. Okay. So that is a data augmentation, augmented data. But you see the synthetic data from the original image, we have to create it. It is not the same dog. You see the original image, and you have see the synthetic image. So we created one data, synthetic data. It is resembled to the your original data. It is exactly similar to the original data. So that is what we have to use the generative AI used for creating the synthetic data. If we are not doing that data augmentation, generative AI will play that, create the similar image. Okay, similar image. So that is the purpose of the generative AI. Okay, whether it is an image or whether it is a text, whether it is audio, whatever it may be the form, whatever may be the your input. So we can able to create the similar kind of input data. So that is the purpose of that your generative AI. So okay, so because why the more the features will be, the more we have to rely with the synthetic data only. Why? Because it is very difficult to get the original data. Already told you, for making your machine learning model or deep learning model more effectively, it is not at all possible to get the data. So we have to depend on the synthetic data. That means from the existing data, definitely we cannot create one. We have to give some input, correct? From the chat GPT also, you are say something, at least you have to give the one word input or two word input. From the one word to two word, it is creating the more number of similar format. So that means from the your real world data, small quantity of data, we cannot able to use for the machine learning model. So we can able to create the more quantity of similar data. That data is normally we called as the your synthetic data. So these are the some of the variations about the generative AI models. What are the important model will be there means here you can able to see GAN. So generative adversarial networks. Another one is auto encoder. We can say it's a variational auto encoder. Another one is a transformer. So there are three variants about the generative AI models are there. Okay. So everything is having the different application. Almost all are you can use to create the your data only, artificial data only. Generative AI, all are generative AI. That means we can create the data. So your transformer is mainly used for the language model. It will lay upon the speech kind of text, speech kind of data means we have to use the transformer. So your GAN and VA almost similar. We can able to create the your image data or audio data or video data. We can use the GAN as well as the variational auto encoder. So these are the different variants about the generative AI models. So before we have to see that generative AI model, at least you should know the some basics about the CN, because your all the generative AI models are internally it is having, we are using the your neural network based model only. So mostly we are using the CNN. CNN is nothing but the convolutional neural network. What is the convolutional neural network means? Because we are giving some the input as a some data we are giving. Suppose some image is giving, from the image it will extract the features. You see that here your the concept about the neural network is, so input layer, hidden layer and the output layer. So your input layer is your input in image. For example, I am giving that particular one image. Okay, so earlier I see the dog, I am giving the dog. So giving the dog, finally your model has to predict that the input image is the dog. Okay, so whatever whether text also there, for example, any digits I am giving, finally I am giving one digit. So finally, it will predict your input digit is a particular number, or I'm giving some alphabet. It will predict it. Finally, it will predict that your input alphabet is a Z or X or Y, something. It will based on your input data. So your input image is extracted into the multiple features. Then it will goes to the hidden layer. N number of hidden layers will be there. Actually, it is a fully connected. It is a forward layers. Okay, more number of neural here, every node will be normally we called as the neural. Yesterday I told you, so based on how our brains, our neurons are constructed, the same format only. So here, and another thing is every node is linked with an one weight. For example, x1 w, it is connected with the weight. We can say it is a every node, one node with another node, it is associated with the particular link is we can call as a weight. Okay. So here you see every somebody you know the image processing, they know that one. For example, how we are representing our input image. So every point is represented as a pixel. So 1 minute, please, 1 minute. So the pixels values are 0 to 255. So if there is no data, it is 0. And it's based on the intensity of that particular value. So the pixel value will be the range from 0 to 255. You see, whenever there is a more dark will be there. So that point we have to represent it as a 255. So you can see the numerical values also, all the numerical values about the particular digit 8. It is similar to the your sorry, similar to the digits only. Okay, now you see, for example, a digit is a 3 cross 3. So 20 into 20 pixels value, 20 into 20 pixels. Then total how many inputs? 20 into 20 is a 400 pixels. Now you see that when we are constructing the input layers, when we are designing a in Python some model, CNN model, when we are designing means your input features will be the 400 according to the your pixels value. According to the your 20 into 20 means 400 pixels value. So that means your every features we have to give as a input. So then number of neurons in that next layer will be the hidden layer. So hidden layer will be the mostly the 2/3 of the your input layers. So that will be the range of the 10 to 400 layers will be there. And the classification, the final class label will be the 0 to 9. Okay. So the output layer, the classification 0 to 9, because when we this is the input image, we have to predict that what is the image, what is your input data. So that we have to say that whether 0 to 9. Definitely the digit will be 0 to 9. So your output unit, we need the only the 10 output classes will be there. So we need the 10 output unit will be there. Okay. So the CNN, how the CNN will process mean here there are the important how many stages are there means you see convolution, one activation function will be there. Any one of the activation function we can able to use. So here ReLU, most of the CNN neural networks will use the ReLU, rectified linear unit. Then another one is a pooling function, flatten and classification. You see, so just I will give the some view about. For example, you see the 2 is your input image. Okay, 2 is the input image. That image will be, we have to find that what is the digit, for your input data. So first we have to do the convolution. So convolution, what will do the convolution? We have to extract the features. Then we have to map with the important, we have to extract, because we have to extract the features first. All the your input values we have to extract from the features. We have to identify that what is your input image. So for the input image, we need the important features only there. So no need for all the features. 0, because it is earlier I told you 20 20 cross 20 or your digit 8. The digit 8, wherever the intensity 255 are very closer to the 255 value there, that pixels only we have to take. That means that whichever the features among the your input features will take the decision for identifying the particular class belongs to which the particular input images belongs to the which class. So that features only we have to extract. So that only we are using that your pooling function will be extract that important necessary features. Then finally we have to flatten and we have to connected that value with the fully connected layer. So that output will give the one function will be there, one softmax function. So that will give the maximum probability value, which input give the maximum probability value, that will be the output of the particular class label. You see here the first step will be the convolutional one. So the convolutional step, what we are doing, we have to extract the important features. We have to extract the important feature. I won't take more time about this one because this is because why I am giving this CNN in this explain here in this generative AI means inside the generative AI we are using the neural network model only. So your all the generative AI models are based on the neural network model. So definitely you should have some idea about the neural networks. Then only it is easy to how the all the generative AI model works. Okay. So the first convolutional part, it will extract the important features. Okay. It will extract the all the features, not only the important features. Okay. So here we are using the some filter. Okay. Here we are using the filter. This is you see 6 cross 6 images, your images. So in the 6 cross 6 images, we have to map multiply with one filter. Okay. So this is the CNN process. Now you see the 6 cross 6 images, we have to reduce to the 4 cross 4. Okay, we have to reduce how every step you have to see 301, 158 and 272, that is multiplied by with this filter. So then we will get the value -5. So first one cell among these three, we have to get the -5. Then among next three. So like that we will take, and finally from the your 6x6 image data input data, we will take the 4x4 output. So this is the convolution. So what type of application we have to use, whether sharpen the data or we have to some, based on that we have to use the filter. So this is the filter is nothing but the some matrix value, some matrix. So that we have to add it in that along with our input image data. So then we have to use the RLU. This is the activation function. So normally, so your neural network model has to map with the non-linearity function. It should not use in the linearity level. So you see here, the f of x is the RLU value. The outcome is a 0 and x. Your value is x is less than 0. It will give the 0 because no need to see that all the important features. No need to consider the negative features. Okay. Because why we are using the activation function means every unit in the your process input layer, hidden layer, output layer, all the layers are interconnected. So one layer or one unit, the input unit or the hidden unit process something, it will pass the data to the next unit. Then it will pass to the again the next unit. So the data has to be propagated one unit to another unit. So that means we have to keep your neural network in the active manner one way. Another one is the what value from the input data, what value we have to pass to the next node. So either we have to pass the 0 means no need to take the your negative values. If the input value is the 0, less than 0, we have to pass the 0. If the input value is more than x, more than 0, then we have to pass the whatever the input you are getting the particular point. So that is what your RLU. This is the one activation function. More variety of activation function will be there. So here we are using the one activation function RLU, and the sigmoid will be there, tan H will be there. So more variety of activation function will be there. Okay. And the pooling. So pooling already told you from the your features. Already we are extracted the feature in convolutional layer. The pooling layer, what it will do means from the features, what is the important features we have to extract. Okay. So there we have to take the either the maximum value or the average value or some value. Here you see that I am using that maximum. So 1156. Here the maximum is the 6. So second one is that how what will take 3 to 1. Then here we will take the 3. So now from your the future map, it will reduce and you will make that some the what we can say then the pool map. So that means that we are extracting. That means from the every stage, from the your input features, we are keeping the only the necessity important features, because that features only decide that what is the image for the your particular input data. So after your the pooled feature map, already told you, we flatten into the single dimensional, one dimensional level. Okay. So then we are using that one softmax function in the last layer. So that will give the some probability distribution value. So you see that probability distribution value. So your first total your classes, 10 classes will be there means among the 10 classes, all the classes, it will all the layer 10 labor 10 units will be there in the final output. Okay, last output layer. So which output unit will give the maximum probability value. So that node is value we have to take as a final outcome. So here 0.9. So that means the digit may be the 1 or 2, whatever the value digits associated with the particular output class label, that label we have to consider as a output. So this is the concept of the your CNN or your neural network process. Okay. So now the neural network only we will use in the your generative AI. So one model first we will see that generative adversarial network. Okay. So what is the meaning of the adversarial, the term adversarial? Normally where we'll use the term adversarial? Anybody? So whenever we are playing a game, correct? Whenever you are playing a game, so what will be there? One yourself, another one will be the opponent, correct? So what is that the role of the opponent? So everybody, if both the player, correct? When we are playing a game, for example, chess game, any one game is there, it is a two player. It is, if a game means there is no game with a single player, no game with a single player. So definitely if you are playing a game, two players will be there. So one is yourself, another one is your opponent. What is the goal for that one? Your aim also to win the match. Your opponent also to win the match. Correct? So both we have to against that particular who is going to the win. So both will not give chance to opponent team. Correct? You will not give easily to the opponent. Okay, you will take the winner. And your opponent, whoever the opponent, that also they may not give the easily chance to you to please take the winning. Okay. So both will compete each other. So that is a normal concept about the adversarial manner. So here the GAN also, it will also work in an adversarial manner. So already told you the neural network. In the GAN, it is consist of the two network. One is the generator, another one is a discriminator. Both are the different two neural networks. Already told you. So generator will be the one CNN and the discriminator will be the one CNN. So that means we have to give the one input image, any one of the input data to the generator, it will find out, generate one output, correct? Similarly, discriminator also, we have to give one input image, it will generate the another one output in the model. Okay, so both two neural networks are there inside the your GAN. So GAN is consist of two neural network. One we can call as a generator, another one is called as a discriminator. So both will be the competitive to each other. Okay, so if the here the thing is be competitive in what the thing means. So the generator, the meaning you can able to understand the thing. The generator will generate the one data. Okay, the generator will generate something or one output. So what is the role of the discriminator? In the whatever you are generating, the discriminator role is to find some fault or find some that means your generated data is not the real one. So that role is to find the fault in your generated data. So you again you are generating next data. What the discriminator will do? So it will find that some fault. Your data is not the original one. Your data is not the original one. I will tell another one simple example. For example, we want to make the one print the fake note. Okay, we have the currency note. We have the currency note. So the generator, now I am printing one the currency note. I am generating the one currency note. So already discriminator, it is having the original note. He is having the original note. It will compare that original note with your generated note. What is it to show that your note is the fake? Then what you will do? Again, you will regenerate the notes. Again, it will find that your note is fake note. So you see, and at one level, the discriminator, it may not able to identify the faulty in your generated note. That means you generated one currency note. If the discriminator is not able to find the fault or the discriminator is identify that this is also real means, that means you generated one fake note. It is exactly similar to the original note. So what is our intention of the GAN? So generative AI. So generative AI concept is to generate the similar kind of data. Already we have one data. So from the data, we are generating one data. The data should be exactly similar to the existing data. You got it? So the generator initially it will generate some fake data, some one sample, one IC data, one IC data. Okay, it is just like a police and a thief. So your discriminator initially it will say that your data is a fake data. Okay, initially itself it will reject. Then what will do? So in the neural network, we have one concept is there, that is a back propagation. We have to adjust and tune. Yesterday I told you when we are adjust the machine learning model, when we are predicting your output is not up to the level, again we got to tune. So here in your neural network also, first of all, for example, you see that I am giving the input image as a 2, the numerical value 2. Our model is saying that your input image is 3. That means your model is not predicted properly. Then already I told you, we cannot change the input value, correct? So already your arrangements, the sequence is same only. The flow process is same only. What we'll do, already I told you, every node is linked with the next node and it is associated with the weight. So that means we have to adjust the weight. We have to adjust the weight between all the nodes. We are adjusting. Second time it will give the 4, then 5. After you are adjusting all the weights, finally it will give the exactly, it will give the your input image 2, your output class also will get the 2. That means how we are doing? We are back propagating the error. Back propagating the error means we are adjusting the weights of between the nodes. We are adjusting the nodes. We cannot able to change the input value. We cannot change the features or the number of nodes and others. Justly we will back propagate the error means we got to adjust the weights between the node. Here also the discriminator identify that fault. Your data is not the original data. Your data is not the original data. Then what the generator will adjust the weights. Again, it will generate the next time. So keep on, it will generating at the one moment. The discriminator may not able to identify the difference between the generator generates the data as well as the original data. That means now the generator generated the one sample similar to the existing sample. So this way we can able to create the more number of synthetic data. Okay. You see, this is the architecture about the how generative AI. You can able to see that. Already I told you that there are two models. One is the generative models. Another one is a discriminative model. The generative model is nothing but the your neural network model. Any one of the neural network. We have the n number of neural network model will be there. So any one of the neural network model will be there. Already convolution, pooling, flatten, all the process will be there inside the your one generative model. Here I am mentioning that it is a deep learning model, one neural network model. Similarly, the discriminative model, discriminator, this is also one neural network model. That means your GAN consists of two neural network models. So now you see what I told you, the generator model as a input as a some noise, random. Because what is our ultimate aim? We have to create one the original note. Okay, the same example you'll see. I have to create some the original note. Already I will use one fake note. Some randomly I will give the some Xerox copy, some normal, some fake note I will give. Okay, that is we can say it's a noise. Then it is the fake samples. Already the discriminator is having some original samples. It have the some original samples. So what it will do? It will reject. So it will compare your fake data with the existing original data. So that if both it will not match, correct, then definitely it will reject the particular data. It will reject the particular sample. So then here what I told you. So we have to back propagate the error and we have to adjust the weight. Here you see the loop. So here we have to adjust the model. We have to retain, update the models. So until one level, your model. So similarly, your discriminator also we have to keep on update the model. Okay. So because here both the layer, both the model, they will try to compete each other. So maximum your discriminator will try to reject the particular sample. Okay, reject the your generated sample. But until one moment, because the value, because that is what it is, both are machine based model only. But until one level, your discriminator model may not able to find any deviations, any difference from the your sampled image. Then that image should be that we have to classify. You see, it is a real or it is a fake image. If it is a fake image, first you are giving one image. If it is a fake image, then we have to back propagating the error. So we have to adjust. We have to adjust. If it is a real, if it is find the real also, that means immediately you are giving one fake image. You assume that if you are giving one fake image, immediately your discriminated model is saying that it is a real image. Then what is the meaning that? That means your discriminator may not able to do properly. Correct. So we have to adjust the both the model because both is a player. Both will compete to each other. So we have to update the here you see the update. The diagram itself you can able to see that. We have to update the generative model also. We have to update the discriminative model also. The first itself, your fake image, the discriminator may not able to identify that. It will identify it as a real means. That means what is the meaning that your discriminator may not able to function properly. So some issue is there in the discriminator model. We have to adjust the weight. So we have to maximum adjust the weight until unless at the maximum level, it cannot able to find the differences in that particular your input image. So this is the way your GAN will work. Okay. Clear? You got idea? Participants? Have you clear about this explanation about how the generative model GAN is working? So both we have to train. Both the things we have to train. Because training, what is the meaning of training? We have to updating the weights. We have to updating the weights. So here your generator will generate the sample and the discriminator will be able to identify that whether it is a fake or real. So that means we have to loss is a function, it is a error function. So using that, we have to update the your discriminator also. Similarly, we have to update the your training also. Both the neural models, both the neural network model has to be updated because they are functioning, their function as the competitive manner. They are function as a in each other. Okay. So now here you see some mathematical about this particular how it is working means you see already the generator. What is the role of generator here? The G is the generator and the D is the discriminator. So there are the two neural networks G and D. So G will be the generator the data and the discriminator will find the fake maximum. It will identify maximum. Its role is to reject the your input data. Okay. So when both are matches, it may not able to discriminate. Okay, that is a discriminator. It is a generator and another one is a discriminator, G and D. So here another two component is there. One is the theta G, another one is the theta D. So what is the theta D? Is the theta D is nothing but the weight. Another one is the theta D is nothing but the, this is theta G is the weight for the generator network and theta D is the weight for the discriminator. Already told you. So we have to adjust only the weights about the both the neural networks, both the models. Okay. So here P of that is your original data because that is a discriminator always compare with the original data. Your noise, your P of Z, that is a noise. Okay, noise as a sample. Noise is nothing but the some sample. Okay, from the original data, we are giving the some similar kind of image. It is not a same image. So this is the original data. Your P of data of X, that is the original data. Your P of SZ, that is a your generator generated the data. So both the data we are giving G of Z as well as the your D of X. So D of X will be the your original data. So here for the training level, when we are passing the P data of X to the D, when Y equal to 1. Okay. So when we are passing that PG of Z to that particular generator, when the Y equal to 0. So both will play in the adversarial manner. Both will play in the adversarial manner. So when it will match that particular data, here you see at the beginning. So P of data, this is the original data. So one is the discriminator data, another one is the P of G, that generator generated the data. So after it's the beginning level. You see after we are updating the theta D, that is the theta D is nothing but the weight for the your discriminator and the theta G is nothing but the weight for the particular your generator. So we are updating the both the thing. We are tuning. At the one stage you can able to see your P of G, that is a generator data also and the original data also almost same. We cannot able to your discriminator level is what is the discriminator value 0 1 by 2 1 by 2 is a 0.5. That means that the threshold value whenever we cross the value 0.5 above 0.5 we cannot able to differentiate. Now you see the discriminator value, the pink color. The pink color is the discriminator. So the P of the white one is the original data and the green color is the your sample data, your noise data. So after we are adjusting, tuning, we cannot change the original data. You see the shape of the original data. The shape of the original data from the beginning itself, last almost it is same. So we are changing that particular green at the particular one moment, your discriminator may not able to differentiate. The value it crossed 0.5 means that means we are generated the one data. It is similar to the your original, similar to the original data. Okay. So this is the way we have to use for generating the particular one sample. So already told you the purpose of the generative AI is to create a similar kind of existing data. Already we have one data set. The data set is not sufficient for finding any patterns or finding any relations among the data. We need more samples. The sample itself, yesterday machine learning model, we have seen some of the upsampling and downsampling. That is, we are creating the same instance, additional one. What is the meaning? We are not creating the new sample. Yesterday, the machine learning model also, we can, in the imbalanced data set, we can make the balance. For that, we are creating the more samples. How you are creating the more sample? Already some samples are there. Same samples or same record, same instance only, we are creating more number of copies. Or we are removing the existing copies. But here, we are creating the new sample. It is not an existing sample. We are creating the new sample, whether it is audio or image or video, whatever it may be. So we are creating the already we have the one data set. Along with the data set, we are keep on creating the more samples without affecting the change the mean. Already initially to given some example without changing the shape of the value here. So this is the way inside a lot of mathematical process will be there. I am giving the just overview about that, how the GAN will produce the similar kind of synthetic data. Now we generated already the white one is the original data, the green one is the we generated the synthetic data. One data we generated. Okay. So these are the some of the generative AI models will be there. You see, already told you text to text. We have to use the Chat GPT. Suppose all are most of the things are open source. Already some of them you may familiar with this kind of application also. Okay, so you can create the text to image DALI, most of the people it may use. Okay, image to text also Chat GPT, image to 3 dimension, image to video. So these are the because one input to the another input, text to text also, text to image also, text to video also. So we have to create the similar kind of data with the help of the these of the generative AI models. So inside the generative AI model, already told you. So it is if you are using GAN, it consists of the two neural networks. One will be the generator, another one will be the discriminator. So the concept based on the whatever I explained that. So based on the process only, it will generate the similar kind of data. Okay. So here you see the some examples. Okay. So earlier I told you, suppose I have the up to t seconds data. For example, t you assume that the 30 minutes I have the recorded data. So from the recorded data, I don't know what about the 30 plus 1, t plus 1, t plus 2. We don't have the particular frame. Already I have the some frames, 30 minutes video. So 30 minutes video means we have the n more number of frames will be there. So from the samples data, we can able to, what is a similar, what will be there in the next sequence? What will be there in the next sequence? That data may not be available. So we can able to create that data from the existing data. Suppose some voice is there. In between the voice is not happening. Sometimes we can see some movies also there. The voice, the speech will be there. Some 5 seconds, the speech will be there. In between the 2 seconds, because there is no speech. Okay. Then after the speech will be there. So we have to identify there what will be the speech, what is the possible speech will be there in between the missing particular times. So that we can able to get it with the help of the GAN. Okay. So mostly we can use the prediction also we can able to use, or we can able to use the generation also. What are the application? We can use the some recognition system or surveillances or healthcare. So wherever we have the some data set is there, healthcare means for example already told you some cancer, some data set we cannot able to get the more quantity of data. So from the existing some data, here you see the T is that already we have the data set. So from the I have 30 minutes or 1 hour existing data. From the data only, we are creating the next sequence data. The T plus 1 and the T plus data is generated by your GAN. Generated by the GAN. T is the existing data. We are giving the input to the GAN. It will generate the next sequence of similar kind of data. Okay. So another one GAN model will be there. This also very interesting one. That is a variational auto encoders. Okay. So already you know the concept of the encoder and the decoder. Okay. So we have to give the X is the input image. From the X is the input image. So your input image is we have to use given to the one encoder. It will extract the features and it will extract all the features. Okay. So from the your input image. from the input, and it will space, it will represent the input image in one space, we can call it as the latent space. So completely some mathematical also will be there inside that. What is the meaning of the math? What is a latent space? Latent space is nothing but it is just like some lower dimensional representation of the higher dimensional data. Your input image in the higher dimensional format, because you are some any input image. So more number of features will be there. We have to extract that. We have to extract that, and we have to represent that particular essential important information. 100 features will be there. From the 100 features, it is a high dimension. The word high, 100 features. From the 100 features, I will extract all the features. I identified, I will make the arrange the sorting wise. I will take the top 10 features. So 100 features will be the original high dimensional features, and the 10 features image will be the latent space features. Same image, we got to represent in the low dimensional space. That low dimensional space is, we can call it as the latent space. Okay, here the mu and the sigma. Mu is the mean and the sigma is the variance. That means already told you the mean and the variance, as it is a standard deviation. Mean and standard deviation plays in the major role in the data generation. The initial slide also I explained that. First one or two slide. What is the role of mean and what is the role of standard deviation? Because we have to generate the data, similar kind of data, we should not affect the mean and the standard deviation. We have to keep the mean and the standard deviation of the original data set, and we have to generate the similar kind of data. So from this data, your input image, we got to represent, we got to make the high dimensional image into the lower dimensional representation, that is called as the latent space. Along with we got to keep that every x, you see mu is at x. The x is the your input image, and SS is the latent space features about the particular image. So we got to find the mu value. Mu is nothing but the mean value for the individual features about the input feature along with the latent space feature. Similarly, we have to find the standard deviation of the all the input features along with the your latent space feature also. Then because your mean and the standard deviation will play the major role in that your GAN, that means the data generation. So then the decoder, it will the probability distribution function, because from that X, your encoder, what will do? Your input image, it will represent the latent space. From the latent space is nothing but the low dimensional features. From the low dimensional features data, again we have to construct the another one image. You see that here the input image is X and the reconstructed image is the X cap. Okay. So here both we will do with some the last function along with the KL. So KL is nothing but the pullback Leiber divergence. It is also one kind of log function. It will map between the your encoder and the decoder. It will minimize the error. We have to, because we have to adjust the weights, because here encoder also neural, decoder also neural network. Okay, we have to adjust the weights with the help of the KL diversion. It is also behind that a lot of mathematical function, some probability distribution function will be there. Some mathematical derivations will be also there. Okay, so X is the your input image. From the input image, we got to constructed the X cap. It is a reconstructed image. You see how we are constructing means your latent space. You see the, I told you the latent space. So your encoder. Okay, the encoder, this is the your input image. So in the input image, the encoder, what it will do, it will extract all the features. It will extract the important features. You see the smile. Smile is the one of the feature. What is the value? 0.99. The value of the individual every features will be the range will be the 0 to 100. The features will be the 0 to 100. One. So smile. You see the image, you can able to differentiate that one 0 to 99 and the skin tone. For example, they will give the range. Okay, 0.85, gender 0.73. For example, male one value and the female one value, and the beard value. He's having the beard is there. Glasses 0.02 because he didn't wear the glass. So then the hair color. So every features, whatever the exact important features will be there. Okay. So this that features this space. You see the latent attributes, because your input image, n number of features will be there, correct? From the input image, 100 features may be there. From that, already told you, latent space is nothing but the low dimensional representation of the your high dimensional input image. That means the latent attributes. That means the very limited number of attributes. It will retain the image also, because we have to identify from the latent attributes, we have to reconstruct the original image. So whatever the features are necessary for reconstructing the original image, that features or attribute is nothing but the features. So that features we have to keep in the latent space. So that is we can call as a latent attributes. It will be there in the latent space, because from the latent attributes only we can able to see that generate the original image. Okay, that will be the decoder. So from the input image, the encoder will generate the latent attributes. From the latent attributes, because many to, you know, the I think some easy, they know the concept of encoder and the decoder. What will be the input in the input encoder will take the more number of inputs and it will generate the less number of outputs. Similarly, the decoder will get the input is the less number of input, that will generate the more number of outputs. That will be the encoder as well as the decoder. Correct. So now you see that here the values for the particular one. You see smile. What is the range? Already told you. 1 to here, 0 to -1. Here the first image you can able to see the particular point for that, where I pointed the value in the point is between the 0 point -1. So that means you see the similar probability distribution. How the maximum this point will be the peak point where my data distribution will be there. So in this range, if I generated the data for the particular image, then it will map. You see the range. Here this is the middle value. Here you see the middle value. Within the particular data distribution, here you see the smile probability distribution. Here, if I generated any more number of, already one data point is there. If I generated the more data points, it will retain the same quality of the image. You see 0 to 1, then the image will be more smile. I hope you got my point. Here you see first image. What is the point it represents? The attribute value is the between -1 to here. Earlier diagram we have seen that. Here you have to see 0.99. Correct. That means what is the value? The values are 0 to 1 and 0 to -1. If he is not smiling, so it is a very closer to -1. So if you want to generate the similar kind of image, then your data points will be within the distribution, within the range only. Similarly, you see the next figure is a Mona Lisa. Normally, you will see that it is exactly smile. Best image for smiling is the Mona Lisa. You see exactly here. Now, within the range, if you create this mean value with respect to the mean and standard deviation, you generate any data point within the range, then it is exactly similar to that one. Similarly, you see here last two, you see the smile where the your graph is there, where the data points are there, more scattered, more data points are there. If you generated another one sample within the particular range, then your data sample will be the similar kind of sample. So the purpose, whether it is a GAN or it is a encoder variable VAE also, the concept is we have to generate the similar data points. The similar data point means we have to find the first, we have to convert, the encoder will extract all the features and it will represent the latent attributes. Here the probability distribution, all the distributions are the probability distribution. The probability distribution find the what is the value for the particular feature. Then from that we have to generate another one attribute from another one feature value. It will be exactly similar to that. What we can say that your input image data. So for that only, for adjusting that reconstructed the image only, they are using the KL divergences as well as the reconstruction process also. You see here how that new data will be there means the decoder, how it will generate means, you see it will generate the probability distribution only. You see that one, your encoder, your input value, the input value, the smile, all the features will be there. In the features, we have to represent the distribution, data distribution range only. So another new data, it will create, it will make a sample within this particular point only. Then almost if you are make the n number of samples, similar to the original sample, within the particular data distribution range. That means if you are make the particular data distribution range, your mean and the standard deviation value will not get more deviated. So your decoder will generate the almost similar kind of data points. Okay, here you see red color and the dot, you can able to see that red color one, another one is orange color. Your encoder will generate the data distribution Okay, data distribution. Within the data distribution, I am creating the image. One is a blue color, another one is a red color. Almost similar because already told you, without changing the, because we are taking consideration of the mean as well as the standard deviation value. So we are keeping the mean and the standard deviation value. We are generating the image. We are generating the data. It won't change. It will not deviate more deviated from the your original data. You see, from the one input image data, now we generated the two similar images. So first one input image is the original data image. From that, we got to generated the two images similar to that your existing original image. So this is the way your variational auto encoder will work. Okay, so the variational auto, because you see all the networks, GAN also there, VE also there, two components. The generative GAN, we have the generator and a discriminator. Whereas your VAE, we are using the encoder and decoder. So both are different networks. Okay. That is, you see, your input x1 is the your input features. Input feature, we are extracting the input features. Then we have to represent that with the mean value, mean and the standard deviation. Then we have to represent the latent speeches. From the latent speeches, again, we have to generate the reconstructed images. So the latent state distribution, we are keeping the mean value as well as the variation. Various, nothing but the standard deviation. Both are square root of the variance is the standard deviation. You see, so this is the another one example also. For example, if you are giving the particular person, he is maybe the age of 50. So our photo also, suppose our, so you are now you are in the age of 30, your face will be there. After 10 years, what will be the your image? What will be the, suppose some crime identification, we have the child, particular person, particular victim, okay, the photo will be there, the young stage photo will be there, or from the child photo will be there. So now how he looks like that? Normally when we are the cyber that people, the police, the investigation time, they are generating the photos, correct? They have the input image is the very old age. That means the either young stage photo will be there. From the input data, we can able to generate how he looks like that. You see, this is the age of 61. Now we can able to generate the another one photo image with the help of the encoder and the decoder. Okay, the encoder and the decoder, we have to generate the another one image. So we have to use this kind of application. Use we can GAN we can able to use. Okay, so these are the some of the open source tools we can able to use for the generative AI tools. So these are the some of the applications where we can able to use, or some of the research area about the GAN also there. So text, image or audio, video or music generation, already main purpose for that only is it is mainly used for the data generation. Okay, are some new, so images also are speech synthesis, drug discovery, so VR, AR development, content recommendations, language translation, some medical image processing, some anomaly or outlier detection, or cyber forensics or cyber threat, cyber attack detection also. So these are the some of the research domains where we can able to use the GAN. Okay, so up to here I will finish my presentation. If any doubt is there. So participants, I hope some give basics input about the GAN and the GAN in the sense two model I explained, because within the 1.5 hours we cannot able to explain more. Hello. Hello.
Sir,
Yes, there is a no.
sir.
Audible, sir. You are audible, sir.
I'm audible. Okay.
Yeah.
Audible,
Yes,
sir.
sir.
Audible.
Audible, sir.
So any doubts or any queries is there? I given some basics about the GAN. Okay, how we have to use the GAN, how the data are generated. Okay, I didn't go the mathematically deeply. So these are the some of the model GAN model we used. Any doubts?
Okay, sir. I think we can wind up the session for third session.
Okay.
So, Arul sir, on behalf of the organization team, sincerely thank you, sir, for delivering such an insightful and engaging session on generative AI. Your valuable knowledge, real-world examples, and clear explanation provided great learning for all participants, sir. We truly appreciate the time and effort you dedicated to making the session impactful. And we look forward to more such enriching interactions with you in the future, sir.
Okay. Okay. Thank you.
Yeah.
Thank you.
Yeah. Thank you so much, sir.
Okay. Okay. Thank you, participants. Okay.
Yeah. So before starting or moving to the next session,
Madam,
yes, sir. Yes, sir.
shall we take a 2-minute break at least?
Uh,
If Nagaraj sir permits.
Sir, let us take 5 minute break, sir. 2 minutes, why, sir? Let us
Okay,
take
sir.
5 minute break. Why? Because
sir.
I can understand everybody might be working in the college and then now coming for the session. So let's take 5 minute break, refresh ourselves, and then
Okay,
I will
sir.
start my session. I think
Okay,
that
sir.
makes sense.
Okay, sir. Uma madam, the
Yes,
session
sir.
will, the next session will start exactly 7:35 p.m.
Okay, sure, sir. Okay, sir. So before that, I just want to give a small announcement, sir. Dear participants, for every session, like attendance come feedback link will be shared in the Zoom chat window. So kindly make sure to submit your attendance as 80% attendance is mandatory to receive the certificate. And we also encourage everyone to participate actively throughout the sessions for maximum learning benefit. Huh? Thank you. So we'll take a 5 minutes break, sir.
இதான் சொன்னோம் சார்க்கு சொல்லிட்டு எல்லாமே அரேஞ்ச் பண்ணி அந்த சில்லாயில வந்து மேல ஃப்ளோர் வந்தாச்சுல அந்த எட்டிக்கு தான் இப்ப கொடுக்க போறேன். எது
Okay, it's time 7:35, so let's start. So now it's my privilege to invite our next session speaker, Dr. Nagaraju Badeti, Assistant Professor, Grade 1, Level 12 from Department of Computer Science and Engineering, National Institute of Technology, Nagaland. So to deliver his presidential knowledge and guide us with his vision for faculty development and research on topic cybersecurity challenges and frameworks in 5G communication networks. Sir, please start the session, sir.
Yes, madam. Thank you. Thank you once again for giving this wonderful opportunity to me, and it's my pleasure and honor to represent the Department of Computer Science and Engineering, NIT Nagaland, which is my parent institution. And I would like to also thank the management, the organizers, and Professor R. Prasad sir for giving this opportunity to speak before you. Before I start the session, like I understand clearly that everybody is busy and this is the second session, right? But there is no other option for us other than me delivering the lecture and you listening to it. Let us make the session more interesting. I can't expect more interactive session. Even if I ask more interactive session, that will not be a realistic scenario. But let us try to understand today, like when we talk about cyber security. Yesterday I was introducing cyber security cyber threat intelligence, right? But today my topic is about what kind of security aspects are required in the 5G networks. So many people may think, like, what 5G networks is doing here in this particular FDP, right? Let us see whether the discussion about 5G networks is related to cybersecurity or not. I will not tell. When the session is going on, you all will realize the importance of cybersecurity is actually based on the network, what we are using. So before I show you the presentation, I want to tell you how many of you are using 3G network nowadays? Is there anyone who is using 3G network? Is there anyone using 2G network? Or tell me one company which is not using the more advanced network that is 5G. I think every one of us are using 5G networks, right? If not the complete 5G, all the application areas may not be on right now, but we are still using the some or the other way we are using 5G networks, right? So I strongly believe that today's my session will be useful to you, and which is in exactly in line with the theme of the conference, the faculty development program. And before doing that, in case if you have any difficulty in understanding the flow, right, please stop me immediately. Otherwise, I think we will continue with the session, and I will try to give 5 to 10 minutes time in the end, if possible. Let me mute my video, so that everybody will be safeguarding their bandwidth. I hope I shared my entire screen. Can somebody tell me whether you are able to see my slides or not?
Yes, sir. Visible, sir.
Yes, sir. Visible, sir.
Okay, thank you. So I start my presentation in the slideshow mode. So today my topic is the cybersecurity challenges and the frameworks in 5G communication networks. For the presentation outline, I hope you are able to see my second slide, right? Can you please?
Yes, sir.
confirm?
Presentation outline, sir.
Then fine. Then that is good. So initially, I would be walking through the concept of security in telecom networks, like how telecom networks are very important for the security of data. Then I will explain the key security considerations, and I will talk about the 5G, which is the future, right? Maybe we are partially into the present also. But why 5G is the future? Why? Because it is not on completely in all the across the globe, but bits and pieces here and there, people are already using it. So I will also have a small walkthrough about the 5G spectrum, the beam forming and beam steering, and then what 5G is bringing to us, the various IoT opportunities, the benefits and 5G use cases, then the evolution towards the 5G and the key technology trends, and then unless until I gave a good background about 5G, you will not be understanding about whether the 5G is trustworthy or not. Definitely, 5G is trustworthy, but what are the steps people have taken to make it trustworthy? That also we have to discuss. And then some security challenges in 5G, the security architecture in 5G, and different solutions to enhance 5G network security. So this is the presentation outline. So as I said, why we are talking about 5G and we are integrating the cyber security concept with 5G. It is in one line, in a layman terminology, if I have to tell, everybody nowadays uses 5G. It can be a person to an organization, it can be a small scale business to a medium scale business and a large enterprise. Everybody's backbone network is based on the 5G network. So we have to discuss about the challenges and the use cases, etc. about the 5G. That is the reason that I have come across the slide deck about different frameworks, the security architectures about 5G. So let's go and dig deep into what is conceptualizing security. What is the concept of security in telecom networks? For example, if you understand, the 5G is the beginning of a new era of network security. You may wonder what 5G is doing with networks, right? Let's try to understand what is a telecom network and how it actually works. To understand the concept of security that is applied in telecom network, in a simple layman terminology, I will try to explain. Right? Now you can see the diagram in the left-hand side. What actually the telecom network does. Everybody knows, right? We have different mobile network operators or internet service providers, you can say, basically, right? Like Jio, ATAL, etc., etc. The telecom network basically transfers the voice and data across the globe with high quality and consistency. That everybody will agree with me. Now, how the data is transferred or how it is transferring the voice? Simple. There can be so many user devices, such as mobile phones, that are staying connected regardless of time and place. You all know, right? We don't switch off our mobile data at all. We want to get connected all the time, even when you are traveling. Unless until if it is a travel by air, we don't keep it in airplane mode. When we are traveling in a train, we expect that in the train also I want to get good internet speed. When we are traveling in a car, many people will fix the LCD screen and they want to watch video. Sometimes we download and watch the downloaded thing, but majority of the time, we are in an era of digital streaming. We are in an era of Internet of Things. We are in an era of massive mobile communication networks, right? So when we talk about the user devices, we would like to get connected all the time and in every place we want to get connected, right? And how is it becoming possible? It is all becoming possible because of the standardization that is being taking place in all the signaling systems and interfaces. Now, coming to the telecom network, every mobile telecommunication network will consist of 4 main logical network parts. Let's see what are they. There are 4 main logical network parts, which you can see in the right hand side. What are they? The first one is the radio access network. Second one is the core network. Third, the transport network. And fourth, the interconnect network. Now, what is this radio access network, core, transport, and interconnect? Right? So I will explain you each and everything. For example, let me, if we are very new, right, to the communication aspect, trust me, I am a purely computer science person from my diploma till my PhD. But when I worked in HP and Tech Mahindra before joining NIT Nagaland, I was placed into completely communication related project where I learned little bit. I also worked all my 5 years of my software career was with the telecom network related projects only. So I'm not an expert, but I can means I worked earlier, right, in the industry with this particular aspect. So when you talk about the radio access network, you know what is a radio access network? Take a mobile. Consider a mobile. The nearest base station, we should not say antenna or tower, but as a layman terminology, I am explaining a non-engineering background. How to understand? Every mobile is actually getting connected to the nearest tower. What is a tower? It is technically in the communication engineering domain, it is called as a base station. That is basically called as the radio access network. I think you know mobile networks are wireless. Wireless means air is the medium. And how we are getting connected is connected through the radio signals. So hence the radio access network. Then comes your core network. What is the core network? Every base station is connected to the mobile switching. And there it will connect to the SGSN, GGSN. They are the core network elements, mobile switching center, where, when you are in roaming, you are able to watch the mobile data, you are able to call. How it is happening, everything is supported by the elements which are there in the core network. Then comes your transport network and the interconnect network, which actually works as an intermediary between your mobile data and the public network. The connection between your mobile network MNO or ISP to the network is done by the interconnect network. Now, every network has 3 different planes. One, the control plane, which actually carries the signaling traffic, not the data. Then user plane, which carries the actual traffic. Then the management plane, which carries the management traffic. I will explain in detail later on when the 5G architecture comes. Then, what are the main assets of any mobile network? See, in terms of any network security, all the 3 planes can be exposed to unique type of threats. When we talk about the control plane, user plane, and the management plane, every plane is prone to get the security. And there are some uniform threats which can affect all the planes simultaneously. So that's why we should understand these aspects of cyber security with respect to different mobile network planes. Then your core network functions and management systems are also critical assets. So what I am trying to explain here is any part of the network is prone to get attacked. That's what I mean to say. Now, what are the main assets of any mobile network? The core network functions, the radio access network, subscribers data, and all the network management related. Right? So what I mean to say is, when you understand the concept of a telephone network, we realize that we are all using the mobile network operator or internet service provider, be it a person or when the network has these many logical network parts, everywhere there is a chance of getting a cyber attack. That's what we should understand, that there are many areas that people, the cyber criminals may attack. Then let's try to understand what is going to happen if the core network is getting attacked. You can see the first point. Suppose if the core network or management systems are compromised, you know what happens? Yesterday I explained you there is a triangle here: confidentiality, availability, and integrity is at stake. Then what is going to happen if my radio access network is attacked? This is the most sensitive asset. Why? Because it is the first point of contact for the user equipment to the mobile network operator or internet service provider network. How you are gaining access to the MNO or ISP? It is through the radio access network. It is the first point of contact which handles the user data, right? So this is a main asset and very critical, which is prone to cyber threat. Then data is the most important asset in the mobile network. Why? Why? Because when our data, when it is roaming around in the huge public network, so-called internet, that is why cyber threat comes from everywhere. When there are, whenever our data is going across various infrastructure elements of mobile network operator to the public domain, that is internet, there is every possibility if the subscriber data gets compromised. It can be voice message, it can be textual data, it can be data sessions, it can be an image data. There are so many things. Nowadays, you know, huge amount of data is traversing across the networks of various infrastructure elements. Okay, it can be like the identity is compromised, the location is compromised, the subscription profile may be compromised, or the metadata, for example, call data records or the signal and traces are compromised. So what I mean to insist here is we need to protect the data of individual subscriber. B means the mobile network. Whose responsibility is this to safeguard? The mobile network operator or the internet service provider's task is to provide high level security to our data, right? So not only the core network, not only the radio access network, not only the data, there is one more thing, that is the network management related information. What is network management related information? It can be the infrastructure, it can be the service configuration, it can be the network configuration, right? It can be some performance metrics, some logs, whatever it is to manage the network, right? All those management information also has to be safeguarded. So what I am saying is the entire life cycle is under scrutiny. So to ensure sustained protection, it is very much important to enforce secure handling of encryption keys and to use so many cryptographic algorithms and various protocols to gain or to give appropriate strength to the MNO or the ISP. Is it fine? Is it clear? Is there any confusion that I am creating, or the session has some meaning? Kindly respond. Is it fine? Okay. So let me continue. What exactly is security with respect to data? Data can be in 3 different forms. When you are sending data, right, it can be a person, as I said, it can be an organization. 1, data in use. 2, data in motion. And 3, data at rest. What is data in use? Right? Data in use means right now, for example, you are accessing the important records of an organization. You are accessing it as a user. and you are a valid user, you are accessing it. Now, at that point of time, the data is called as active data. It is stored in various databases. It can be in a data warehouse. It can be in a simple spreadsheets, etc. When data is being used, it should be safeguarded. Now, data is in motion. What is data is in motion? You are sending data across a network. You are sending data across a network. Now, when you are sending data across the network, sometimes it can be stored temporarily in one of the element which is part of the network infrastructure. So the data has not reached the destination or the intended user or an organization, but in between the network, it is being transmitted. That is called as data in motion phase. Data should be safeguarded in that phase also. Now, there is another phase which is neither active nor in travel or communication phase. Data at rest. What is data at rest? You know, majority of the data, when it is not active, it is stored physically in various databases. It is archived in tapes. It can, for a safety backup, we might have taken some data backup. So right now, nobody is using it, but it is at rest. What is it? Data at rest? It is in a warehouse, right? Anybody can access it. But when nobody is accessing it also, when data is at rest, it has to be safeguarded with equal priority, like data is in use or data is in motion. So, as I said, this is the triad. Yesterday also we have come across this confidentiality, protection of data. Confidentiality has to be maintained even when the data is in use, data is in transit, or data at rest. Now, integrity. What is integrity? You have to protect the data against any changes which are not legitimate. Then availability. Irrespective of the attack or the network outages, the data should be available to all the intended users without any network interruption. 5G promises confidentiality, 5G promises integrity, 5G promises availability. So, this is what the data security is all about with respect to any network. Is this clear? I just want to give a pause for a minute. Is this clear? Or any doubts? Till now, is it fine? There is no response, so I will get a doubt whether I am audible or not.
Audible, sir.
Okay. Thank you. Thank you. So let's continue. Now let's talk about various operation means what are the different key security considerations that we have to see. For example, any telecom network security, they are defined by the following layers. What are these layers? These layers determine the network security experience of the end users. For example, you take any network operation, right? The operational processes that allow the networks to function and deliver target levels of security, they are highly dependent on the deployment and operations of the network itself. For example, the first layer is to secure or to monitor the security performance and to response and recovery after every breach. Then the next layer is the deployment process, which talks about the solid network design with security and resilience in mind. The third one is vendor product development process. What we do, we actually, during the development process itself, they have to think about how secure my hardware and software components are, how secure my development process is. And every vendor, when they are developing a product, they will think about the version control. They will also think about the secure software update as well. Finally, the inside layer, which talks about the telecommunication standardization process. Whenever you are bringing any standard, you have to talk about the security in the protocols, algorithms, and also the storage level. So, as I said, these are the key security considerations that every telecom network standard or the operator will follow. Now, let's try to understand what exactly is 5G and the future next generation mobile communication is all about. 5G offers 3 different application areas. 5G, I'm talking about a layman because 5G itself takes a lot of sessions to explain. But for everybody to understand, what are the, what is the difference between every generation? As a layman, tell me, what is the difference between 2G, 3G, 4G, and 5G? In general, I am asking. Can somebody respond? In general, what difference you feel when we come across various generations? Can somebody please respond by unmuting themselves? Okay. No response. So let me try to understand. Every generation promise better data rates. I think everybody will agree with me. For example, the internet speed which you got in 2G mobile is nowhere compared to 4G, and now when 5G comes, it's beyond our expectations, right? One of the main application area of 5G which promises is enhanced mobile broadband. The standalone user speed is 10 gigabytes per second. Standalone user. High mobile user, 5G promises 1 gigabyte per second. Just gigabits per second. Just imagine. You are talking about faster connections in a wireless medium with higher throughput and more capacity. Then the second application area is ultra reliable, not reliable, ultra reliable, low latency communication. The latency which is expected is 1 millisecond, less than 1 millisecond to be precise. So we can't imagine the speed in which the 5G wants to give to the users. And another one is massive machine type communications. What is this? Massive means, high volume. Everybody is now having a flat IP address. 5G is also called as a true flat IP network. What do you mean by flat IP? You have a smartwatch, it is having internet connectivity. That means it has an IP. You talk about a sensor, it is connected to a network, it has an IP. You mention anything. People are now living in the Internet of Things society. I think everybody will agree with me. So 5G is expected to support gigantic volume of devices which are connected to each other. For example, 5G is called as the connected community. 5G is called as a connected community. Here you can see there are some smart homes. They have some access points. They are connected to the network. Some small business, large business are there. They are also connected. The stadium is connected. Schools, shopping centers, smart farms, transportation. the individual user who is walking around in a small park, everybody is connected to everyone. That's why 5G is called as connected community. You know what is a connected community now? Everybody is connected. You know, gated community, right? In big cities, we have a huge number of apartments. We say gated community. Well, why it is called as a community, right? You understand now? Like that, 5G helps you to connect to those communities. It can be virtual reality, it can be education sector, so many. So 5G uses several radio waves or frequency energy to transmit and receive voice and data connecting our communities. Now, when huge amount of data is emitting from each and every community, just imagine how much error prone it is. Whenever you say cyber security, it starts with the network. It starts with the point where your data is going into the gateway. From the gateway, it is connected to the public network, that is internet. Now here internet is everywhere. Everybody is connected to everyone, and they are heterogeneous networks. One good thing in 5G networks is it supports 2G, 3G, 4G, and it supports femtocell. It supports multiple different types of networks, which we say head nets. 5G truly supports heterogeneous networks, right? So let's go further about. See, first of all, I want to give a platform of what exactly is 5G and why we have to talk about cyber security in 5G, right? As I said, 5G is always in integration with the 4G. For example, initially, see, right now, 5G is actually working alongside with 4G. There will be one day where standalone 5G also will start. Some places it is already there. As of now, what we are trying to use is 5G. Okay, when 5G connection is established, the user equipment will get connected both with the 4G. Sometimes you see, when there is no proper 5G connection, you are immediately getting a 4G connection. I think you can see in your mobile. Sometimes it is 5G, sometimes it is 4G. Why it is coming? Why? Because right now they have integrated 5G alongside with 4G. So what happens is, whenever there is a limited 5G coverage, the data is carried over the 4G network for giving you continuous connection. For giving you continuous connection. So 5G is complementing the 4G right now. Now, as I said, there are two different things: non-standalone 5G and standalone 5G. So as I said, I think you know what is LTE, long-term evolution. 4G is technically called as LTE, right? So sometimes in non-standalone, what happens? Here you can see EPC. EPC means Evolved Packet Core. What is Evolved Packet Core? The core network management system in 5G is called as EPC. What is NR? New radio. I will explain what is new radio in the upcoming slides. So in non-standalone network, what happens? You have support. You can see the data plane, which is the continuous line. You have the control plane, right? In standalone 5G, as I said, it can operate individually. It can operate individually. You can see in the right-hand side, 5G core, new radio is supported to the user equipment along with the 4G. But in non-standalone, what happens? Everything happens in integration with 4G, right? Then let's continue. So here, there is one good technology that is coming with 5G. It is called as device-to-device communication. What is device-to-device communication? Let us understand. You know, we know Bluetooth, we know Wi-Fi. Wi-Fi and Bluetooth, they don't use the licensed spectrum. There are two spectrums, One is licensed spectrum, another one is unlicensed spectrum. You know, walkie-talkie, where the defense people or the train diver and the, in the earlier guard, the train guard, railways, I'm talking about Indian Railways. Guard used to show the flag, green flag. Or in the night, they used to put a green torch light. Engine driver will see, then only he will stop. That is my old and when I am in the childhood days, I used to see. Later, I think everybody might have realized they were given walkie-talkie. They are given walkie-talkie because the length of the train is so much and every platform is not in a straight line. It is in a curve. So the flag of the driver or the guard is not visible to the driver. So what they will do? They have given walkie-talkie. You may wonder why I am taking this example. Walkie-talkie also works in unlicensed. So what is this unlicensed spectrum? Your Bluetooth, Wi-Fi, terrestrial radio access, that is TETRA, that is your walkie-talkie, right? They all use unlicensed spectrum. What does it mean? It means that it will not use the macro layer. I will explain you a simple example of what is macro layer or macro network. Macro network means, try to understand your user equipment, that is your mobile, laptop, etc., etc. First will connect to the base station. Then it will go beyond the base station. This is the normal macro network. But in unlicensed spectrum, your Bluetooth does not go to the base station. Your data will never go to the base station. Okay, that's why the access is physically limited to a nearby area, less than 1 meter, 10 meter like that. You understand what I am saying? But people are now coming with so many ideas to connect to the devices directly without using the macro network. But if it is in another area, I could have explained more, but to cut out the discussion, I want to explain you 4 different categories of different communication which is going to be promised exclusively by the 5G networks. Let's see the first one, DROC, the first diagram, device relaying with operator controlled link establishment. I will explain you nicely now. You know, before actual data transmission, you need a link establishment, the control link establishment. That will happen using macro layer. And relay. What is relay here? Suppose a mobile is in the edge of the cell. I think, please observe, I have given a hexagon shape here. Inside the rectangle box, I gave an hexagon shape which represents a cell. You know, cell means a hexagonal shaped cell. Imagine there is one node which is far away from the base station, but within the cell. But you are not getting enough strength. So what I can do from by using this device-to-device communication, I can use some nearby devices and I can use a relaying concept. Relay, you know relay, right? Here, if you can see the first diagram, the control link happens between the base station and the devices, right? And the data can be transferred by using the relay from the source to the destination. Now you see the right side link. Direct D2D communication with operator controlled link established. Here what is happening? I am talking about the top diagram right side. Right? Here what is happening? The control link will be established with the macro network, but data will be transferred directly from source to destination. So what is this direct transfer? Without the intervention of the macro network, people are going to offload the traffic. So where it will be used? Just imagine, you know, long back, there was one cyclone attack in the area of Visakhapatnam. called as Hud Tufan. I think many of you, if you are from Andhra Pradesh, you will immediately realize, or many, that time, the Prime Minister sir was Prime Minister only. He came to Visakhapatnam and there was a news. Nobody is able to contact with anyone. Why? Why? Because all the towers are blown away with the cyclone. When the base station itself is fallen down, you know, I am living in a hill stations, hilly terrain, not hill station. Nagaland is a hilly terrain area. I think majority, you know, in Uttarakhand, in Nagaland, in Manipur, in Mizoram, in Sikkim, in Meghalaya, Mizoram, Arunachal Pradesh, you know, northeastern states, right? We are all living in a hilly terrain areas. So much of landslide happens. Sometimes the tower itself is gone in the landslide. Then how you people can connect? That's why people are trying to use this direct device to device communication so that people can contact, or for example, a building has collapsed. A building has collapsed. How you know whether somebody is there or not? So whether a person is alive or not, or he is in a difficult situation, most likely they will use their smartphone. 100%, I can't give a chance, but there is a high possibility somewhere a mobile will be fallen down. If you can identify the nearest device, you can identify there can be a chance that one person may be there. You know, many times by seeing these kind of catastrophic events, people are unable to identify whether the person is there or not, one person is alive or not, we don't know. So people are going to use this direct device communication. Then the next diagram you see, there is device relaying with the device control link establishment. You can see how the data is being transferred from source to destination by using several devices with relay and without relay. Are you able to understand? The top diagrams with relay, but control is with the base station. Without relay, control is still with base station. Third diagram and fourth diagram, there is no control of the base station. The control itself is happening within the, there is no control of, there is no intervention of base station at all. Control is also between the user devices with relay. On the right side, you can see direct. So these are various not the technologies that they are going to support with respect to 5G. Now you tell me, when everything is open, right, without the control of base station, there is more chances of cyber security threats. Just to encourage everyone, I just want to show you a small case study here. Imagine there is a movie called as Star Wars, right? If you use 1G, it will take nearly 5 months. If you use 2D, ideally it takes 5 days. But if you use the true 5G, the theoretical maximum speed it is giving is 20 Gbps within 1.7. You know, many times I am downloading Amazon Prime Video within a minute. Within a minute, I am able to do. Sometimes 3 minutes. That's all maximum time I will take. Just imagine the highest quality I will always select when I am watching. Within 3 minutes, I am able to download the movie. How it is possible, right? It is all possible because of the various technological advancements that are happening with respect to the 5G. Now, what are the possibilities that 5G is going to enable us? You talk about telemedicine, which is giving greater access to the healthcare, and you know, many times in movies also we saw robo will do the operation, or nowadays everything they're still on. I mean, may not be completely full-fledged in our nation, but there are people who are doing surgery, but they are not physically present. In 3 Idiots movie also we saw Amir Khan is performing some operation, right? Much before 3 Idiots, there was one Tamil movie called as Endiran, which is dubbed as a robo, where Rajinikanth, the andro-humanoid robo, will perform a surgery also, right? Actually, these are all possible now. It is many places it is happening. And you talk about the autonomous vehicles, more safer cars to avoid better collision avoidance systems, Internet of Things, autonomous drone. Everybody talks about drone. And we saw recently Operation Sindoor, how India has given lesson to our neighbor who is not our well-wisher, right? I am not going into that arena, but everybody now talks about drones and autonomous drones, right? So virtual reality and augmented reality and high level of industry automation is also being supported by 5G. I think most likely very soon in another couple of years, we will see the complete installation of 5G across the globe. Now I want to tell one more basic about the 5G. The 5G spectrum, they use new radio, which is the new spectrum, which is above 6 gigahertz. The spectrum, when the complete true 5G comes, that's why everybody, when if you want to use the 5G SIM card, you have to mandatorily buy a 5G mobile. I think everybody will agree with me. Why we have to buy a 5G mobile to use a 5G network? Because 5G offers so many new things, and the spectrum which 5G offers is above 6 gigahertz, which was not supported by the earlier 4G mobiles. That's why we have to forcibly buy a mobile which supports 5G, right? So increased spectrum, greater capacity, more users are getting connected, and faster data speeds are also coming. In existing mobile spectrum, we are using below 1 gigahertz for like TV, Wi-Fi, and we are using 1 to 6 gigahertz, right? But when you talk about new mobile spectrum, it is way beyond what we can imagine, right? This is not a right arena to talk about macro cell, small cell, etc. But I just want to tell you that 5G spectrum is completely new. Why? Because the 5G new, it is more flexible, more reliable, it gives high throughput, and it is not having much latency also, right? So let me just come. One important thing, why we are getting more strength in the signal, not the signal strength I am talking. How it is coming, how you are able to get more data rates. One technique is called as beam forming and beam steering. Please try to understand. See the left side of the diagram, 4G macro. Till 4G, the radio signals go in omnidirections, means all directions it will go. But with the beam forming and beam steering, you see there is a 5G macro based on the user. The radio access is almost targeted to the end user only. So by adapting the beam pattern, you are forming a beam in such a way, it will give you more data rates and more continuous connections. Then I will skip few slides. Okay. As I said, there are so many benefits for 5G. For example, one is in the automotive and mobility industry, where we are talking about the autonomous vehicles. So every autonomous vehicle takes lots of data packets and emits lot of data packets. For example, it can be applying an emergency brake. It can be also an in-vehicle speed warning. There is no driver. You are going in a speed. All of a sudden, there is a speed limit indicator. Immediately, it has to apply brake. But immediately, if it apply brakes, what will happen? What will happen to the car which is going coming in the rear side, right? So you have to use an adaptable speed control mechanism. For example, for red light warning indicator, or when there is a curve and there is a cooperative forward collision warning. For example, there is an vehicle going before you. You can't go in the same speed what you want to go, right? Usually what human being will understand, they will calculate the distance between the vehicle which is going before me, and automatically we will apply the brake. But when there is no driver in the manual driving is not there, you have to calculate the speed between the vehicle which is going in front of you, which is going in behind from the rear end also. Then you have to apply the brakes so that collision will be avoided. Now you may wonder what is happening in this. Why? Suppose if somebody starts attacking this place. For example, somebody will attack in the particularly the transport network, then there can be a huge collision. Or somebody will try to, for example, entire traffic management is automated. Just imagine everybody is getting an indication that so and so traffic is there in Y junction. Please avoid the junction Y. Go in A and B and reach the place Z. Something like that. Now just imagine if there is a cyber threat and people will purposefully, what they will do? They will purposefully hack the systems and make sure all the traffic is diverted to a place. Maybe they are planning something there. So they can actually target the network and they will change the network into such a scenario where people will go in a direction where the cyber criminals are wanting the people to come there. I hope you are able to understand what I mean to say. So there are so many opportunities where the 5G is used. It can be IoT, it can be smart city, it can be healthcare, manufacturing industry, energy sector, right? People are going beyond the, what is fixed wireless access? If there is a wired connection, Ethernet port and all, you understand, right? If there is a wide connection, internet will be very nice, means more data rates. People are now trying to give such data rates in wireless medium. That is what it is called as fixed wireless access, right? Now, coming to the IoT device security aspects, as I said, everything in 5G is based on flat IP network. 5G started, the development of 5G started in 2010. And it started coming to the people from 2020. It is still in the transition period. From the beginning of the research of 5G, Internet of Things is already in place. That's why 5G is called as IoT era. 5G is called as IoT era. So 5G is basically built to support IoT. That's what I mean to say. So whenever we say Internet of Things, there is internet. Whenever there is an internet, there is a cyber security threat. So while IoT device security is a critical component of any IoT security posture, it alone cannot ensure any secured IoT solution. So you need to understand, like there is a high possibility that cyber criminals will try to target this particular network. Now, what people has to do? People has to plan in such a way the 5G networks. This is one more slide, which I think I already talked about connected communities. So this is another use case opportunities. Let's talk about industrial Internet of Things. Internet of Things is there. Industrial Internet of Things in Industry 4.0. Everywhere 5G is available. So what I am trying to say is mobile IoT is going to come in the 5G future. Initially, we start discussing about IoT in the year 2000. But once the 5G comes, it is going to support the mobile IoT also. Critical communication, enhanced mobile bandwidth. So these are the use cases which 5G is going to support. Now, let us come to the aspect of virtualization and cloud-based technology. 5G is the first generation which is actually built on the concept of internet. Earlier, virtualization was not used in any on a larger scale. But 5G is completely designed based on the cloud-based technology. Whenever you say virtualization, you understand virtualization, right? Whenever we say cloud-based technology, it's all, the 5G is not at all static. Everything is based on cloud-based technology only. Software defined networking, SDN, software defined networking. What is a software defined networking? Let me just tell you a very brief about software defined networking. What exactly software defined networking does, you know? It will, I will tell you a simple example. I already explained you control plane and data plane. Usually, control plane and data plane are tightly coupled till 1G, 2G, 3G, 4G. Tightly coupled. What is this tightly coupled? Imagine a traditional network, not 5G. I am talking about before 5G. Imagine control plane is a brain, human brain, and data plane is the muscle. They are completely tightly coupled within a same network device. For example, a router or a base station. They are tightly coupled into one device. So, why they are tightly coupled? What is the necessity of control plane, data plane here? Control plane will decide how packets should flow, how to take a routing decision, what is the quality of service, how mobility management will happen. All the control decisions are taken by the brain. Like that, no. Then the data plane is the actual packet which is routed, which is the decision taken by the control plane. Imagine your brain has decided lift a weight. Brain is actually giving to the signal to the hand. Hand is actually carrying something, but who told the signal? Who gave signal to the hand? Brain. If brain, the control plane, and the data plane are together available in the same device element, then they are called as tightly coupled. But now, with the software defined networking, which is completely available in 5G, what it does, it is decoupling. They are loosely coupled now. What is loosely coupled? The control plane and data plane are not existing in any physical device. Why? Because everything is now virtualized. Now, what are the advantages of this? The centralized intelligence and distributed forwarding. For example, the control plane is separated and it is placed in a centralized SDN controller. So then what it will give? It will give a global view of the entire network, that is about the 5G network, and the decisions, everything will happen in more intelligent manner. Then the data plane is available in the device itself. So basically what happens here, people are now not restricting everything to a particular device. Rather, people are decentralizing. People means the 5G standards. They are decentralizing. That's why NFV, you can see here, network function virtualization. The entire network functionalities are being deployed in the cloud. The moment we say cloud, it is error prone, right? So, as you know, the introduction of AI and powerful computers together with the cloud technologies, they are the key evolution and the technology beyond the 5G. Right? Distributed cloud computing will make the resilience of the 5G network slicing. Let me just explain you why I am explaining this is in every area there is a problem of a cyber security threat. what is network slicing. I will try to explain you with a simple example. Okay, we are having there is a family. There is a family who want to have bread. Who want to have bread. What we do? We take the bread, give different slices of bread to different people. Similarly, just imagine initially, imagine there is a 4-line road. Imagine there is a 4-line road. Everybody is going. There is no discipline, line discipline. Cycle is going, auto is going, car is going, etc. There is no rule. But imagine we bring some rules like there is a extreme left line, left side line. For people in express highway, you can see all these things. What is express highway? Concept of express highway. Slow moving vehicles go in one direction. 60 to 80 kilometers go in this line. 80 to 100 go in the third line. More than 80 or more than 100 kilometers go in the right line. What is this? We are using the same road, it is the same battery, but we are slicing the network in such a way people of different requirements can travel on the same road without disturbing the other people. Sometimes we change the line, but imagine there is no such in an express highway. For example, if you go to Mumbai-Pune express highway, in many highways also, they are earmarking clear things. That concept is called as network slicing. Concept is called as network slicing. What we are going to do with network slicing, we are now trying to give the bandwidth for everybody in such a way they think they are only using, but everybody using the same network by having a different virtual slice. I hope you are able to understand. Right? Now, there are several security threats that can happen to the network thing. One such thing is called as slice hopping attack. Slice hopping attack happens in network slice. For example, imagine a person who is buying a cycle ticket. For example, in a highway, you are selling tickets. Cycle means one ticket. He has to go in one line. What he will do? He has taken the cheapest line, that is cycle ticket, less expensive. But he will go into the ambulance line, which is the fastest line. Then this is a slice hopping attack. People will take one slice, but they will try to access the another slice. Are you able to understand what I am saying? Every slice has a proper rate. For example, cycle line, normal ticket. Ambulance line, highest ticket. And just in between, different tickets are there. That is different line for different people. So what is the threat here? Hackers may try to jump from low security IoT slice to a critical hospital slice. Similarly, there is another attack that can happen in the network slicing, that is denial of service attack. What will happen? Purposefully, thousands of trucks will intentionally block all the lanes of the highway. What will happen? Attack is network one slice with fake devices consuming the. Then people will not get the access to that particular line. There can be another attack in the network slice that is called as a data theft, eavesdropping. What will happen? There will be a spy. He will hide near the road and listens to all communication, ambulance communication on the fastest. Then what will happen? They will get access to the highest confidential information. There is another threat that can happen in the network, that is slice misconfiguration. I am going to give all the notes to you. Okay. Sometimes I am explaining more, but it's not in the script, but I will give all the presentation also, you will give the notes. By tomorrow evening, I will share all the notes with both messages. By tomorrow evening. Slice misconfiguration is, for example, a traffic police accidentally route bicycles into the ambulance. What will happen? Because it is misconfigured, no? Then people will travel in the ambulance like with a sign, obstructing the ambulance. So I am taking a simple example of a road. Then there is another network slicing kind of threat, that is noisy neighbor problem. What will happen? There will be a music band on a first lane. They are playing music in such a way, they are so distractive that the ambulance drivers in the first lane are getting distracted. So what I exactly am trying to say is, if one slice consumes too many shared resources, it will affect the other slide also. So what I mean to say is, in network slicing is the core, uh, what I can say, core technique or the technology that is being given by the 5G, and there are so many instances that there are chances of cybersecurity threats. Then let's try to understand what are the, now I have explained you basics of what is available in 5G. 5G is completely cloud-based network. Now, when we talk about, see, so basically what we are doing here, no? 5G means internet. Internet means there is a cyber security threat. Then how you can create a trustworthy 5G system? How you can create the 5G security, the trustworthiness is based on 5 important aspects: resilience, communication security, identity management, privacy, and security assurance. Let's try to understand what is resilience. Okay, I will try to explain you with a simple example. What is the meaning of resilience? The system can keep working even though there are problems, failure, or attacks. Means continuity. Basically, resilient network is something which is more fault tolerant. Let us try to understand an example. Imagine there is a hospital that always has a backup generator. If main power goes, immediately generate it so that the doctor can still operate the patient. For example, let us bring an analogy in 5G. If one cell tower fails, if the system is able to quickly reroute the connection so that your call or a video does not drop, then you can say it is resilient in nature. 5G offers resilient networks. The second thing, communication security. What is communication security and what is the meaning of it? For example, protecting the messages or data being sent so that no one can secretly read or change them. Then we can say the communication is secure. For example, when you are sending a letter, sometimes if it is a confidential, what we do, we put it in an envelope, we seal it so that only receiver can open, right? So in 5G, how it is being achieved? Suppose if you are sending your bank details while shopping in online, encryption ensures hackers will not read or steal the information. Then the third aspect of a trustworthy 5G system is being given by identity management. What is the meaning of identity management? You make sure only the right people or the devices can use the network. For example, you know how you are going to unlock your phone with a fingerprint or Face ID, right? Why we are using a fingerprint and Face ID nowadays? Because it ensures only you are going to use it. So in 5G, for example, your SIM card, the SIM card proves that your phone identity is not being given, or it is not, the identity is not revealed. The identity is not revealed. Your SIM card itself, when you are using the 5G SIM card, it itself proves that you are not fake, but you are the real person. Now, that is what they are offering us. The next one is privacy. I think you know, protecting the personal information so that it is not being exposed. For example, when you are going to a shopping, you don't tell the shopkeeper, no, where is your address and all. So in 5G, your exact location or browsing history is not shared with any strangers. But still people are trying to hack. That is a different thing, right? We'll come to that. Security assurance. So 5G actually does regular testing, certifications, and lots of auditing is going in the background so that operators and users can trust that the network is safe. The network is safe. So let's continue. So what is the vision of 5G? The vision of connected society is becoming the reality with all the trustworthy attributes that 5G is going to provide. Now, there are so many security challenges, right? Various challenges. Yesterday also I have explained you some key challenges. So let's see. In network slicing, I have explained you different attacks. Now let us try to understand what are the various attacks like the distributed denial of service attack, man in the middle attack, slice attack I already explained you. So there are several device vulnerability attacks. There are some Ethernet layer attacks, right? And there can be an attack in the gateway also. There are different places that there is a chance of security threats. Now, having said all these things, this is another slide which talks about moreover the different security challenges, right? When 4G and 5G exist together, it requires high performance security with more consistency. Now, when more devices are connected, hackers get more opportunities to attack. As I said, virtualization and network slicing also bring new risks. Manual operations are not enough to stop any threats. So that's why cyber threat intelligence is required to support a safe 5G network. Then various security challenges for the service provider. We are talking about the 5G standards. Now let us talk about the security challenges for a service provider. Who is a service provider? The person or the organization, not person, sorry, the organization which is giving us the mobile network subscriptions or the internet service provider. First of all, the first security challenge is lack of visibility. Due to large complex network, everything is connected to everybody. That's why it is not Internet of Things anymore. It is Internet of everything or Internet of anything. Anything means that here thing requires an IP. If you are able to, if you have an ability to connect to the network, then you are on to it. Then the capability to effectively detect and respond to security threats is one of the security challenge. Another one is the digital transformation, which is happening right now. That is a challenge. Then how to regulate the things and the compliance requirements. How to become compliant, right? That is also one security challenge. And then financial risk, the IT data breach, etc., etc. They are also one of the security challenges of service providers. And majority, there is a cloud adoption. The moment cloud comes, obviously there is a risk of cyber threats. Having said this, 5G has come up with a security architecture also. There are 3 different levels of security. I think I have explained you in the initial slides. One, the layer 1 is the least, the first level. That is when the vendor is actually developing the product, there itself they will provide the security. It can be at the base station level, it can be in the core infrastructure level, or it can be at the router level. The next thing is how best I can include my security at the network level. And the last layer is how best I can give the security in the top level. That is where the application security comes into picture, right? So in all the layers, 5G standards are developed in such a way in each and every layer people safeguard the network. Now, when you talk about the system-wide security in 5G, right? So there are various layers where, for example, if you see the horizontal security, it can be at the network level, network slicing level, application level security, as I said, maintaining the confidentiality and integration protection, right? In each and every level, 5G standards are being developed, keeping in the mind of the highest level of security that can be offered to the users of 5G, right? So there are various levels, which I have already explained. We are running out of the time. So the last slide, okay, is, okay, in what way or what are the solutions that can enhance the 5G network security? So let's talk about the concept of what kind of solutions that can be given. Okay, just give me a minute. The first thing to enhance the regular risk assessment is, regular risk assessment. Just give me a minute. For example, you have to, you means the people who are providing the 5G standards, right? They are thinking about periodic risk assessments, right? So this is required. Why? Because periodic risk assessments are always been very important, and repeated risk assessments and analysis of 5G use cases will help the stakeholders to eliminate cybersecurity risks from non-trustworthy devices to the to make it a rugged system. Then the next solution is you need to have built-in security for IoT devices. More simultaneous connection of IoT devices actually increases several attacks, right? So one solution to handle this increased risk is to ensure stronger security at the design stage of IoT devices itself. So to achieve more and better built-in security, there should be a specific regulatory body for the IoT devices, which actually help standardize the industry and protect the customers and the infrastructures, including critical infrastructure. Then there should be a standalone 5G network. So ultimately, 5G infrastructure will be maintained the way other digital systems are maintained. It's a digital updates, patches, and updates. As I said, currently 5G exists in conjunction with the 4G physical network infrastructure. So we very soon, right? One of the issues with IoT devices is they are currently connected to the 5G using the existing 4G infrastructure. So security transmissions between the devices and nodes are sent in a plain text, making them vulnerable to being exploited by the hackers. So very soon we need the solutions which work on the standalone 5G cellular network. Then one of the another possible solution to enhance the network security of 5G systems is to have an improved network security and data transfer. Promoting collaboration is another solution. For example, 5G offers a unique possibilities, right? Where there should be a cooperation between manufacturers, governments, retailers, internet service providers, and rather than somewhat adversarial relationship between business and regulators, there should be more transition towards a proactive and collaborative system where people will come together and they will develop a secure network. Another solution is information sharing. You know, information sharing is very critical to protect the 5G network because the technology has so many vulnerabilities because the technology is new. So it only takes one weak link to make others network vulnerable. So keeping everyone up to the speed there needs to be a special focus to work on specific security issues with respect to information sharing. Then another solution will be in the aspect of real-time threat detection. How we can detect a threat in thanks to the artificial intelligence using AI, we can detect the cyber threats, which improves the speed of the threat detection and mitigation. Right? While 5G means an increasing in the attack, actually 5G means it is increasing the surface of the attack. Why? Because everything is internet based. But it also offers huge potential to mitigate the threats with faster detection and better management thanks to the AI and machine learning technologies. Right? So we are going to have an artificial intelligence and machine learning based network management. So you can detect the cyber threats in a more proactive manner. And the last but not the least, one solution is you have to implement cyber security best practices. What are the best practices? You can say, for example, using a VPN when connecting to any internet connected devices, or you can have a multi-factor authentication system, or you can obviously have stronger passwords, or you can also implement access control, which restricts the access to sensitive information and mission critical data, or updating the devices and apps regularly to ensure any vulnerabilities are patched up, or the final thing, we have to install anti-malware software, preferably with a threat detection system. So there are multiple opportunities, right? So I'm giving some references to you from where I have taken all these slides. So in an overview, what exactly I am trying to tell you here is 5G is the network that we are using. 5G is the core or the heart of the communication system right now. As I just stopped the presentation, as the 5G opens up the complete internet, you may not be able to see because my light is gone, but still I hope I am audible to you. So 5G introduces virtualization and a complete cloud-based network. When you say internet and cloud-based network, there are so many vulnerabilities which I have explained completely, and various solutions that we can provide also I have explained. So here I stop my presentation. Now, actually, no, the topic is very vast in nature. Usually I stop in between, but I am not getting even a time. Only 1 minute I just stopped in between. But yesterday and today, I have been continuously explaining like a one-way unicast only. So please forgive me. All the my email and information is given to you. In case if you want to have any collaboration research also, I am welcome you all. My number is also given. By tomorrow evening, I will give the notes, presentation, everything to Professor R. Prasad sir, so that he can share across to the all the audience, the faculty, right? So there ends my presentation. Over to the audience and organizers. I hope I have given some kind of valuable insights to you. Thank you for everyone for your patient listening, and thank you everyone for this opportunity.
Thank you, sir. Thank you very much, sir.
Thank you. Thank you.
Nagaraj sir, we extend our heartfelt thanks to you for delivering a highly informative and insightful session on cyber security challenges and frameworks in 5G network communication networks, sir. And your expertise and clear explanations gave participants a deeper understanding of this critical domain, and you greatly enriched today's session, sir. And we are eager to engage with you again in future knowledge sharing opportunities. Thank you,
Thank
sir.
you, madam. Thank you, madam.
Thank you,
everyone.
so much, sir.
Thank you, everyone. Happy learning for the next 3 days. Thank you.
Thank you all participants. Thank you. And tomorrow's session, fifth session will be starting at 6 p.m. So we look forward to everyone and join the session in time. Okay. Thank you. Thank you all.